The first part of your homework tonight talks about word problems based on the stuff we did yesterday. Okay? So that page 352, that's talking about some word problems. So I wanted to talk through those with you a little bit. Okay? So it says the value of a mountain bike can be approximated by this model. Y equals, thank you, 200 times 0.75 to the t power. Okay, 200 times 0.75 to the t power. The value of a mountain bike can be approximated by this model, where t is the number of years since the bike was new. Well, if you know that t is the number of years since the bike was new, and you can see the equation that it's given to you, tell me, is this mountain bike gaining value or losing value? Losing. Okay, give me at least two reasons why you know that. Okay, so the common ratio is less than 1, right? Okay, what's another way you could know that? So common sense, right? The older the bike gets, the more damage it gets, all that kind of stuff. So two different reasons that we can know that this is, what did I say again? This is what? Oh, decreasing. Oh, yeah. Okay. So the mathematical, you know how we always like to make sure our mathematical vocabulary is good? Apparently my English vocabulary is not any good today. This is actually called exponential decay because the value is decreasing over time. Okay? So can you tell me by what percent that it's decreasing? Are you sure? Because thinking about last night's homework, we rewrote this equation, didn't we? To be what? One minus what? 0.25, right? Because 1 minus 0.25 is 0.75. So now can you tell me what the decrease is? What's the rate of decrease? 25%. And we had already decided that was a decrease, right? Estimate the value of the bike when, let me start over. Estimate when the value of the bike will be $50. So when will the bike be $50, worth $50? Earlier, they figured out 3 different ways to do this problem. What are you doing? Right now, what are you doing? You're graphing. So you're putting that equation in a graph, and then what are you going to do? Check the table. Okay, so let's see if I can show you what he's doing. On, home, new document, that's a graph. And so he's putting in 200 times 0.75 raised to the x power. Did I break it? I just can't see it, right? It's not in the right window, but I'm not really caring about the graph. What am I caring about? The table, Control T. So what am I looking for? 50. Where am I looking for 50? In the Y. Why am I looking for 50 in the Y? Yep. T stands for the time since it was new, so Y is how much it's worth, right? So if I'm looking for this, well, it goes from 63 to 47. Is that a good enough estimate? Between 4 and 5, is that a good enough estimate? Not really, right? Okay, so let's go and write that down, though, so we know. It's between 4 and 5. Can we say closer to one or the other? Probably closer to 5, right? Okay, so are you saying now that I could take the 4 and the 5 for the x value and start putting numbers in for the equation? Oh, yeah, that's a great idea. What do you want to put in, 4 or 5? You don't want to put either one of those, do you? You already know the value for 4 and 5. We want to choose a value that's close to 5. What value is close to 5? 4.5. Okay, I'll go with that, but we'll have to have a talk about that later. 200 times 0.75 raised to the 4.5. 54. Is that close enough to 50? No? Okay. So we tried 4.5 and that was 54 and something. So what do you want to try instead? 4.3 is going to get us closer to 4, and that was the 63 one. 4 point what? 7? That's 51. 4.8, we can try it, right? 0.75. Oh, yeah, that's right. Raised to the 4.8. Ooh. Sorry, 4.8 is 50.2718. Now, I need you to remember what the vocabulary was in the question. Estimate when the value of the bike will be $50. Does it say get exactly to $50 OCD style? No. Is 4.8 an acceptable answer? Yes. We don't need to try to go at 4.85 or 4.84 or 4.8. We just need to settle down and be okay with 4.8. On your own time, if you want to go find out what it is, you just go right ahead. But here's the deal. Why didn't we just put 50 in right there and solve this? You don't know how yet. That's exactly why. Exactly why. Exactly right. Okay? You don't know how yet. And it's not time to show you yet. That's why we're estimating and not getting an exact answer. Okay? It's just not quite time for that yet. It's a little foreshadowing for the future. Okay? So that's the kind of word problems that you're going to see. Are you okay with those? All right. Then let's talk about today's actual lesson. It's called Recursive Functions. We will not be writing in cursive again. We will also not be cursing again. Okay? Although if you would like to write in cursive, that's totally fine with me. Although if you would like to curse, that is not fine with me. Okay? Okay, here we go. Recursive functions. Recursive functions are a different way to write an exponential function. Okay? Now, you know how sometimes we have these things that we do and you're like, okay, seriously, Kingston, cannot be that easy. Like they all stared at me second period. Like seriously, what's the hard part? The only thing I can do to make this hard is make the numbers really big or put fractions in there. But even then, it's not even hard. Okay? So here's what you need to know with recursive functions. For every problem, you're going to write f of 0 equals a. And then for every problem, you're going to write f of n equals r times f of n minus 1. A recursive function is a way to list all the values in the function as long as you know this term. So let's pretend that I know the fifth term. So f of n is the fifth term. Then what term is this? Yeah, the fourth term, right? So recursive functions are a way to list all of the values of the function as long as you know the term before it. Now, I know that when I give you an equation like this is the one we've been working with, right? A times b to the x power, or like we talked about the other day, a 1 minus r to the x power, or to the t power, I think is what we used then, but x is fine. Guys, this r and this r are not the same. What does this r stand for? Rate. And what do we usually talk about when we're talking about this rate? A percent, right? A percent that we've changed into a decimal. You okay with that? Okay, this R right here stands for the common ratio. Oh, I apologize for writing cursive. Okay? This R is a common ratio. It is not this R. Okay? Is everybody okay with that? Okay, so here's what I want to give you an example. I don't know where my paper went. There it is. Here's your example. Y equals 8.3 times 1.4 to the x power. Now we can use some of the stuff we talked about over here because these a's are the same value. What does the a mean? Do you remember that? Yeah, that's exactly right. It's our starting value. Okay? A is our starting value because if if x is 0, then that's a 1 and I'm just left with the a. But here's the thing. F of 0 is what we're writing anyways. That's our first term, isn't it? So does that make sense why that's our first term? Because I'm putting in 0 here and I'm just getting the a value. Does that make sense where that came from? So in this particular problem, what is a? 8.3. Okay, let me make sure this is clear. This, what I'm underlining, is the problem. And this is what I'm writing underneath is the answer. Okay? So if I've written f of 0, what else do I have to write? F of n. So f of n equals the common ratio times f of n minus 1. So all I have to really figure out is the common ratio. Guess what the common ratio is? Yeah, it's the base. That's the ratio that is changing by every time. 1.4 times f of n minus 1. And we're done. Yeah. Okay, let me see if I can make it harder. Whoops. Y equals 749,000 times 0.26 to the x. So that's the problem. What two things do I have to write as my answer? F of 0 and f of n. Do we know f of 0? What is it? 74,900, right? What is the common ratio? Times the previous term. Guys, that's the only way I can make it harder is by making these numbers bigger or smaller. That's all I got. You don't have to find out what f of n minus 1 is. Nope. All it's asking you for is the recursive function. This is the recursive function that goes with this exponential equation. Now, if I ask you to list the first 5 terms, could you do that? Okay, so f of 0 would be what? Well, we already know that, right? What about f of 1? What's f of 1? Well, if we're finding f of 1, I say 0.26 times f of 1 minus 1. Does anybody happen to know what 1 minus 1 is? Okay, so this is 0.26 times f of 0. But don't we know f of 0? It's right there, right? So it's 0.26 times 74,900. Do you know that off the top of your head? No, but it's something we could calculate really quick. 0.26 times 74,900. 19474. So f of 1 is 19,474. Okay, so far? What about f of 2? Wouldn't that be 0.26 times f of 2 minus 1? Okay. Oh, good. 2 minus 1 is 1. Excellent. So we have 0.26 times f of 1 except we just found f of 1, didn't we? 0.26 times 19,474. And again, while we don't know that off the top of our head, that's something we could easily calculate. 5,063.24. And we could keep on going, right? To the third term or the fourth term or the fifth term, when in actuality, all I want is the rule. I just want this. But this is how you use a recursive function. So if we're just finding a list of the terms in the function, recursive functions are really helpful, right? But if I want the 7th term, is this really helpful? If I want the 7th term, I have to know the 6th term. And if I need the 6th term, I also have to know the 5th term, and then the 4th term and the 3rd term and the 2nd term and the 1st term and the 0 term, right? But if I use this exponential equation right here and I want to know the 7th term, don't I just have to put a 7 right here and find the value? So they're both valuable for their own reasons. And my TEKS require me to teach you both of them. So there you go. So if I give you an exponential equation like this, can you give me the recursive function that goes along with it? Okay, here's your quiz that's no grade. There's the equation. What is the recursive function that goes with this? You be quiet, write it on your paper. What we need is f of 0 and f of n. Can anyone tell me, raise your hand, if you know f of 0? Does anyone not know f of 0? That might be an easier question to ask. Okay, altogether, what is f of 0? 42. Altogether, what is f of n?
0.96 times f of n minus 1.
Done. Got it? Any questions?